Welcome, everybody, to developing enterprise-ready plugins. Are you ready to explore deep space? For me, that's not so much a joke. My cubicle neighbor is a member of the last 100 of mission Mars 1. And so if he makes it into the capsule, he will have a one-way ticket to go to Mars and have his tombstone over there. But I guess we are talking actually a different enterprise here. So could I have a show of hands? Who runs a Jenkins server or multiple Jenkins servers with more than 250 builds? All right. I visited my first Jenkins user conference last year, and to my biggest surprise, a lot of enterprise Jenkins users were also developers of plugins. Who here has tried to develop some plugin, has developed some? All right, so I know why you're here. I want to share with you some of my insights of developing for a while plugins. First, I want to tell you how we started with plugins at Black Duck. Our first plugin was written by a sales engineer. It replaced some shell scripts that our users used with Jenkins to automate our ProText scans. And it also automated the generation of some projects. And before we knew it, a few months later, probably 6 months later, we had 10 users, 4 of them having problems. Do I get here some feedback? So my team and myself took over. We are a group within Black Duck that develops standardized, productized integrations. And we made sure that the #1 concern was addressed, slave support. And we had some class loading issues, solved those. We made sure that the Black Duck tools were installed on demand. And before we knew it, about 10% of our ProText customers used the Jenkins plugin. Let's see if I can adjust that feedback. Something I can. Let's hope it stays away. So what I want to talk about today is what do we think is enterprise ready. I want to talk specifically about the credentials plugin because we have started using that in our plugins, and I think it makes a world of a difference. I want to also talk about supporting REST APIs, and I want to talk about a plugin that is not ours, but an open source plugin, but we love it. It's called the UpdateSite Manager plugin. And then at the end, I will also introduce you to a free offering that we from Black Duck have introduced with the Jenkins user conference. So you might wonder, who am I? I'm the integration manager at Black Duck Software. So I have architected and co-developed 5 plugins. I'm familiar with most of the code. Our plugins are used by lots of large organizations. And I'm also responsible for other types of integrations, whether it's IDE integrations, other CI systems. I also am responsible now for REST APIs to our cloud knowledge base, and I'm the author of 3 of our classic product APIs and SDKs. For those of you that don't know what Black Duck does, Black Duck is in the business of helping you to manage your open source. We mainly discover open source in your source code or in your binaries and or your dependencies. We help you manage the licenses and the obligations that come with that. And we help you to catalog all your use of open source, which comes in really handy in cases of security vulnerability reports. If something like an OpenSSL bug hits you, then with that catalog in hand, you know in an instant what applications you have to really look at, and you can make a priority list and work on it as fast as possible. Why do we care about the Jenkins CI? Well, we have determined, and our customers validate that when code is in the CI system and gets built on a regular basis, that is a point where you really want to check all those additional checks, whether it's your static code analysis or our type of analysis. Because if you find issues with that code through those tools, you want to make a stop-or-go decision. And Jenkins specifically because our customers requested. So a few lessons that we have learned by developing plugins. For enterprise customers, it's important to support master and slave configurations fully, of course. We need to support all job types that are relevant. We do some work with Maven and Gradle, and the Maven Jenkins job type needs support from our side, and we can't just ignore it. We want to minimize the configuration, because if you have hundreds and thousands of jobs to manage, then that becomes a pain to just even enable our plugin and all those jobs where it's relevant. And as one of the tools that we really found useful is scripting. We see a lot of enterprise customers having jobs that create jobs, or having other external scripts that create jobs. So the ability to script your jobs and the plugin with it is important. Another important consideration for enterprise-level plugins, in our experience, is the versioning. You really have to give a lot of thought of changes in the configuration and how upgrade to the next version will work. You have to make sure that your new version can read the configuration of the old version. Or if that's not possible, because they're really different, then you want to find alternative strategies. And we have done that with our first plugin that I was speaking earlier, to make scripts that migrate. So we have written job generation scripts. We use them extensively. We also found them very, very useful to create lots and large numbers of regression tests. We have to work with two variables. Jenkins is upgrading all the time, and our own systems have new versions and releases. So we want to make sure that we are testing regressions in both directions, and that often means to deploy another set of 50 or 60 regression scripts with different variants of configuration, and make sure that all the APIs in our own system, as well as within Jenkins, still work. So scriptability comes in very handy. The credentials plugin. It's a very logical thing to do, but I've seen plenty of plugins that I'm very familiar with not to do it. Who here is familiar with the credentials plugin? Oh, surprisingly little. It is part of the Jenkins standard, but it is a plugin lately. I think it used to be just part of the core. It manages your usernames and passwords that you might need for other systems, or potentially SSH keys, so for remote logins to deploy and things like that. It stores those kind of artifacts in a secure way. You can define them once and use them everywhere, so you don't mistype the password in one job and then it doesn't work. And you have the ability to fine-grain the authorization there, which allows you to manage it centrally. And people that are allowed to create and manage their own jobs might not even know the password for the system that you're actually integrating with, like our Protect system, which I think is really neat. So this was our first approach to those things. We have a field here where we configure our own server connection, and we have a field that has the username and the password, and then some project name that gets created, potentially, or that gets connected to. These fields get repeated in every single job. Times 500, painful. So the better solution is to use the credentials plugin. That's the middle field here on that screen, where you then have the ability to define and just select the credentials from a list. And in this case, because the user that uses it here has the authorization, you can even add one on the fly if you don't find the right one, but you could restrict that to the management area. And we have done the same thing in the server area. We have defined our server connections which are typically only a handful in enterprise, with our product centrally. And then you can select from what is there. No mistyping, no chasing bugs because somebody didn't type the right way, the URL there. This is the pop-up that you see when you add a credential. You can give it a name. You can give it some scope. So you can even restrict access to those things by scope and authorize access only by scopes. You can define your username and your password, and you can give it some additional description, like what authorization does that user have in the third-party system. Now, I wanted to talk here to the developers as well. It seems those kind of things might be complicated, but it isn't really. It's very simple to use. Thanks to Jelly, all we have to do is here the red part and the top line. We have to declare the namespace against that lib credentials. And then we replace a regular f.select with a c.select, and that's all we have to do in the UI. And then on the code side, you want to write a method like this that goes and gets a credential provider, static class, a method to look up the credentials with a few parameters, what kind of class you're looking for. In our case here, nothing is specific to the project, so the project is null. The domain requirement for us is also empty. You could set here restrictions. And then you get an ID matcher, and you loop over the various credentials, make sure they are of the right type, cast them, and that's what you need. That's what you're done with. And now we have an object that has a username and a password decoded from the secure storage for us in our application to use. Wasn't that complicated after all? Our other love is the REST API. Who of you has used the REST API around Jenkins? Oh, a few more. Don't be afraid of it. It's really your friend. It's a very convenient way to script jobs. You can pull and save lists of jobs. You can query lists of jobs. You can create jobs from an XML description, and you get the job configuration as an XML description. And you can update jobs, change things on it. And so our before described mechanism to create jobs often goes simply and takes a certain list of jobs, downloads them into a file. Then we go and change with an editor, with an easy search and replace some names and play the whole system back into the system, and we have 60 new jobs. Takes less than 5 minutes. But your plugin needs to support it. But don't be afraid, the support is really not that hard. What you need to implement is this method that you annotate with the method name config.xml. And then you have here a section in the middle, I don't know if you can see that, where you define what the get method should do, what a post method should do, and any other HTTP verb should throw a bad request exception. And you have to also implement your update by XML if you want to do more than reading the material. And in your update by XML, you get a stream. You can read the information that comes in, interpret the XML, save it into your configuration object of your plugin, and hit the save method. And that's all there is to it. Here's a little example of XML that we have in our own built environment, where we have the server info, the server name, server URL, some timeout. I show that especially because you see here that the credential is just a UUID that you get to see. So this doesn't expose your username, password credentials that you just made safe, where otherwise if you have those fields, you would exactly see here freely the username and password mechanism. The third thing I like to promote is this UpdateSite Manager plugin. It's really for those that build their own plugins. if you're having multiple Jenkins installations, then you struggle with the situation that you have to take your plugins and upload them from a file. And that's not the most convenient way, especially you are missing the convenient update manager, plugin management update screen where it tells you, hey, there is a new version available. So your distribution becomes more cumbersome. You have to email to everybody. You have to reach everybody. There might be, I don't know, in our organization, Jenkins servers have a tendency of springing up somewhere, and we don't know that they all of a sudden exist. Sales engineers create their own Jenkins servers to do demos, and they might not be in the list to get the updated plugins. So what you can do with the UpdateSite Manager is you can build your own UpdateSite Manager that works right in the list of managed plugins as you're used to from the corporate, the general open source Jenkins update site. It's using the same mechanisms. It polls, I think, daily to look up if there are new versions. If there are new versions, it shows you that you should update. It recognizes the kind of things that you do in your update, in your plugin definition, where you say, hey, this is only compatible with these kind of versions of Jenkins. So it will tell you that it might not be compatible with the version you're running. It does really all the very basic things about the Jenkins plugin. So in practice, when you install that, you find it on the regular Jenkins marketplace. When you have installed that, you see in your managed Jenkins this manage update sites entry. And there you have also the default update site, which might be your LTS URL or your hot off the presses latest, greatest. And here we have added our own internal update site. And that's really easy to maintain. You give it an ID. You give it the URL where this thing lives. You might add some note. And if you want to, you can also secure the connection with an authoritative certificate so that you really know that the server is the one that you're expecting to talk to and nobody has intercepted that. You might now say, well, a private update site, that sounds a lot of work. It really isn't. It is well documented. All you have to do is either deploy your artifacts into an appropriate file system structure, or you can deploy it as well into a binary repository like Artifactory or Nexus, which you might do already. At least we do it. Then you have to re-index the repo. So as a practitioner tip, I would recommend not putting it in a global, big repo, but create your own repo for your plugins so that you only have to re-index that one, because that might have a performance hit on your binary repo, the re-indexing. And then there is a site generation script, which is the very site generation script that Jenkins on their central side uses as well. And you can run that with the appropriate parameters, and the result is an XML file that describes your update site, and that XML file gets checked and downloaded and compared with what is installed. Works beautifully. Detailed information here on that GitHub URL. What you don't get is the nice formatted wiki pages that you see with every Jenkins plugin. There is nothing really in detail hindering you, except because all that code, how to generate those things, is checked in the GitHub repo of Jenkins. You can find that there. The URL I just mentioned earlier describes the process. The biggest problem is that Jenkins still uses a Confluence version 3.4.1, which means the Confluence API is version 1, which is not supported anymore on current Confluence versions, which are 6.2. something. So you're losing out on a macro that creates you this gray box at the top of your Jenkins plugin, which is the information about how many installs you have, which is information that comes out of the POM file directly, about where there is some kind of issue ticket problem channel where there is support to be available, where the homepage for that plugin is, which is usually where you are, and author information and those kind of things. They come directly out of the POM file of your plugin, but that macro is unfortunately not yet ported to the 6.2 or to the API version 2 of Confluence. We have not yet found the time to do that ourselves. If we get around to do that, we'll probably donate it back to the Jenkins community and hope that they adopt it and can get away from their old Confluence version there, which is, by the way, not very secure anymore. At this point, I'd really like to shout out to Ikeda Yasuyuki, because he's the author of this plugin, and we really find it awesome. It just makes our life so much easier on different systems to manage our own plugins. And we are going to deploy that more to customer-facing plugins as well in the near future. Here comes a little bit of the self-promoting part. Black Duck Software has recently, actually with the East conference in June, launched a free security offering to allow anybody without our products to do some security screening. These pictures don't come over well visually. Before I explain what's going on in that plugin, let's explore a little bit how a developer typically approaches open source use. The main question in their mind is, does the component do the job? Because without it, it's useless. Is it well documented? Is the API cool to use? Is it convenient for me? Do I get the latest version? Maybe the developer asks, is it efficient in terms of memory, in terms of performance? But most developers care little about licenses. However, the developer's manager should ask more questions. He should ask, well, does the component do the job, right? But can we accept the license? Is the component secure? Even when I have shipped, I still want to ask the question, is that component secure, or is there already known security holes that I should patch by a new version? And if there are vulnerabilities reported, often they're reported on the component level or with some vague description of what versions are affected. I want to really know, is my organization using that version? So the vulnerability report plugin that we have offered here to the Jenkins community goes and monitors Maven and Gradle builds. So you have to live in that build environment, otherwise you can't really make use of it. It captures all the dependencies that get resolved in the CI, which is most likely the build that you're actually shipping or deploying. It checks it against the Black Duck knowledge base and pulls license information as well as vulnerability counts from the National Vulnerability Database. And here I had planned a live demo, but unfortunately we have power outages in our office. We have construction in the whole office complex, so I give you a slideshow demo. I start kind of at the end because that's the more interesting part. So when you have that plugin installed and configured and run your Maven job or your Gradle job, then you end up with this entry in your menu, the Black Duck vulnerability report. And this is how this thing looks like. It's a list of your components. We have taken the GAV, mapped it to our knowledge base, pulled back the information about the license, the third column, as well as the 3 numbers about counts of vulnerabilities on that particular component. At the top, you see a summary with this little bar graph. And those labels of that bar graph, you can select them and therefore filter your list down there. You might have quite a lot there as components. And you see there the classification of high, medium, and low vulnerabilities, no vulnerabilities whatsoever, and unknown components. Those are often those components that are not open source, that are your own code, your own components. we have no information about those. You can also go and export this data in a CSV file format. So you can throw it into an Excel sheet to do more data analysis with it. You can email it. You can attach it to a Jira ticket and ask the developer to change versions and figure out how to get rid of this vulnerability. Configuration is very, very simple. All you have to do is, in case of a Maven job type, to select your Black Duck vulnerability Maven integration, if that's what you're doing. And then you list the scopes that you want to have included. By default, it lists all scopes, and then you can take away. If you're not interested in vulnerabilities in your test code, that's fine with me. Looks very similar in the Freestyle configuration, just more options because there we differentiate between Maven and Gradle. The Gradle configuration is a little bit different because Maven has fixed numbers of scopes, where Gradle has a variable number of configurations, which actually include each other. So you have to know a little bit more how they are constructed about it. But you can basically do the same thing. And if you have assembly configurations and other configurations, you can just add them here if you want to have them scanned. And then you get detailed information in your console output when the job runs. You can see here in the second line, it clearly indicates what version of the report was run. And you can also analyze here that we are setting a Maven extension class path, which adds a few components that we are adding here in order to do this job of monitoring the Maven job. Looks very similar in the Gradle way. Here, of note is in the last few lines, you see the detailed dependency information as we pull it back. So what you see in the report, you see also as symbol entry lines in the console log. And with that being easy and simple and effective, and it being Jenkins, just use it in every build because it does things automatically. And if you have security vulnerabilities, the earlier you detect them, the easier it is to mitigate them. Because typically you don't want to ship anything that has security vulnerabilities. Oops, I have this twice. My little motto, friends don't let friends ship software with security vulnerabilities. We have a sponsor booth. If you want to have more specific questions, feel free to ask. You can find me on Twitter. You can find my company on Twitter. I'm on Google+ and LinkedIn. If you want to stay in contact or have questions that come up later, feel free to email me at Black Duck Software. And if you want to have more information about the vulnerability plugin, this is the URL where you can find it. And thanks to our sponsors. This conference is great. I hope you're enjoying it as much as I do. We have many very interesting conversations with a lot of people. I learn from a lot of you because I'm very interested in listening and hearing the practitioners, what they do, so that we can help them. Thank you very much.